Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I'm doing this mainly to improve my skill sets and hopefully in the process you will learn something as well. As always, double check anything you see or hear in my videos. There are people far more experienced and capable out there than I am. If you do enjoy the video, please take a moment to like, subscribe, and comment below. With that said, let's jump right into it. Today I'll be designing a URL shortening service. I want to convert long URLs into unique short aliases. When a short URL is accessed, redirect to the original URL, capable of handling thousands of requests per second. I would imagine that would be write requests. Support for a user-defined URLs. Monitor and record statistics for each URL click, implement functionality to delete expired URLs. Alright, with something like this, I'd like to jump right into the database schema design. So we definitely want a link table, and then we have link ID, we have original URL, we have short URL. We have a date stamp when this was created. It says implement functionality to delete expired URLs. So we can have an expiration date stamp. And this can be null here. If it's null, it doesn't get deleted. And if it does have an active date, we use that to determine when to delete this URL. We definitely don't want to delete this URL from our system. We simply want to do a soft delete. And we will simply have a column in here called delete. And the reason we do this is because we don't want to generate a short URL that was used previously and then have the historical topics or posts or social media posts pointing to that URL and get redirected to some place completely different. Next thing we want to handle is monitor and record statistics for each URL. Well, the simplest way of doing this is simply have a click counter here. While that's great at helping us figure out how many times a URL has been clicked on, it doesn't help us understand when and who and where this URL was clicked. So we were going to have a new table called link click. Here we will have a link click ID. We will have a link ID to associate it with the correct link. And then we will have a date stamp. Now there are many metadata points you can capture here. We want to leave this open-ended, so we'll simply say in addition to that we'll have other metadata. Now that gives us a hint as to how we want to store these and with what technology we want to use. For our link URL, we know that it will be very low volume, and with our link clicks, we know we're going to have very high volume and unstructured data. So we can save our link table into a MySQL database. That will ensure that as the service grows in complexity, maybe we want to add users, maybe we want to add companies and enterprise level types of services, we can expand that and maintain those relationships using MySQL. Now, because our system won't be will mainly be writing the link activity into a database that's used later on for the statistics, we can use a NoSQL database. And MongoDB would be great here, able to handle high volumes of writes, and depending on what clients want, they can collect different metadata, and that unstructured data property of MongoDB really helps out here. Alright, so now let's go into next phase is we definitely want to be capable of handling thousands of requests. Whenever you have a URL shortener service, you don't know from where on the planet this thing is going to be utilized or clicked on. And you want to make sure that you have the lowest latency possible, because it becomes annoying if you have to click on a link and then wait for it to redirect you. So whenever you have a global service, you will have at the very least two load balancers. One is a global load balancer and the other is a regional load balancer. The regional load balancer will then direct your request to the most appropriate gateway. And there are many ways of determining how you direct a request, right? There are many algorithms, round robin, least load, lowest latency. It all really depends on how you want to configure your regional load balancer and what works best for your system. So this would be how we would handle the request and determine what to do next. So let's talk about creating a short URL. Now this is simply passing a URL to our system and getting back a short URL. So we will take that request. The regional load balancer will pass it to the global load balancer will pass it to the most appropriate regional load balancer based on where that request is coming from, and based on the algorithm you've decided, it'll pass it to the right data center and the right server. And from there, we will immediately take that request and have a service ready to handle it. So we will have a new, let's just call it service, new URL service. This will take this request and pass it on to our new URL service. Now, our new URL service will take that new URL and generate a shortened URL. And to do this, it has to first check whether the URL it has generated already exists, or it does, or if it already exists, and if not, move forward with it. So it generates a new short URL, and then it checks to see if that URL already exists in our database. If it does, it regenerates a new one and repeats the process until it finds one that is unique. Now, the only problem with this is because we're getting thousands of requests per second, having to hit the database each time is really slow and process intensive. So instead of that, we will have a dedicated service that we will have a caching service that will contain all the URLs ever generated by our system. So the new URL service will take a look at the cache to see if whatever short URL it has generated is unique, and if so, continue forward. If not, generate a new one until it has confirmed it is a new unique short URL. It will then send that response back to the original request and return the short URL. Now, in addition to that, what we also want to do is make sure we save this. So let's go back to the gateway. We will write this into a topic. And here we will have handle new short URL process service. And what this will do is it will be subscribed to this topic. And for every new URL, it will add one. It will save it to our database. It will write it into our all URL Redis server. And then, in addition to that, it will also write to our active URL Redis server. All right, so let's see what happened. We requested a short URL. It was handled by a new URL service. It determined what short URL to use, and then it sent that new short URL back to the user, and it saved that information to a topic that was then processed by handle new short URL service. That service wrote it into our all URLs Redis server, then to our MySQL database, and then also to our active URL service. Now what we're going to do is redirect. So we're going to get a short URL here that's sent to the system. We will then have long URL request that will handle that request. It will look into our active URLs and determine if it exists, and if it does, sends back the long URL. Or rather, original. Now, if it hits the caching server and it doesn't exist, it will then ensure that it doesn't exist in our database. And if it doesn't, it will simply send a null or an error message. So that will handle getting the original URL from a short URL. The next thing we want to do is allow users to generate unique custom short URLs. It's going to be basically the same thing. In this, if we look at our API, we will have create. It will be a post request, create, and our data points will be and short URL. String null. Now, the only difference will be that if we are sending a string back, now the system will determine, hey, is this a unique URL? If it isn't, it'll send back an error message saying this URL is already in use and ask the user to generate a new one. Next, what we want to do is take care of implement functionality to delete expired URLs. Now, this will be a job and we can run this every hour or so. That will check, that will well, we can run this once a day. So if we limit expiration to be in days rather than hours, this makes our system much simpler and allows us to run this job once a day. And what it will do, it will look at all the active URLs, and then based on the expiration date, we'll update the database to say it's been deleted and flush that record from the Redis server. It will not touch the all URL database because that will contain all the URLs that we will have throughout the history of this service. Now, the next thing to do is really talk about scalability here and making sure that these systems are synchronized. Now, what we want to do is definitely we want to have our databases located remotely and use database as a service, and this will allow these systems to scale and adapt accordingly based on our system needs. Same thing with our Redis servers. We will, instead of being a single Redis server, these will be clusters. This will allow for redundancy and fault tolerant. Same thing with our database. And then in addition to that, we want to definitely build our system on a KA, on a KA infrastructure, so that we can scale these things horizontally as we deem them necessary. And if we need to scale the clusters as well, because each KA node has a limited amount of resources. If we exceed those things, we also want a cluster scaler. So all our services would be built on top of Kubernetes to ensure that as the system scales, we can configure it to scale automatically. Alright guys, that's my attempt at designing a URL shortener. Let's quickly look at this. Again, convert long URL to unique short alias. We've achieved that. When a short URL is accessed, redirect to the original URL. We've achieved that. Capable of handling thousands of requests per second. We've been able to do that. Monitor and record statistics for each URL. We have our database, we have our data structure right here, and we've dedicated a MongoDB database to record all those activities and then generate whatever statistics we want in the future, and implement functionality to delete expired URLs, which we have by creating this delete expired URL job that runs daily to ensure that only active URLs are still present in our service. Okay guys, if you have an idea for a system design that you'd like me to do, please post a comment and let me know. If I've made any mistakes, I would really appreciate some feedback and some direction. Thank you so much. Have a wonderful day.